How was the party yesterday? Everybody was there? Maybe not? Okay. So sorry for starting a little late. We're going to talk about implementing high availability with PostgreSQL. So I've been doing some high availability implementations already in the past, and I've been contributing to PostgreSQL too, so that's a list of what I've been doing and what I'm doing now. So I done the create extension framework and now working on event triggers so that we can get DDL support in the next in-core bidirectional replication. And I intended to work on partitioning, and that's kind of a running joke because each and every year the current work is expanding 1 year more, so partitioning is delayed. I'm going to show you some proven architectures. About every diagram of an architecture you will see in that talk has already been running for some years in production. Okay, so the main angle of it is not a theoretical review of how to do things, but back from the field experience about things that really work in production. And most of them, I've been implementing them at iMedia, which is a mid-scale public-owned company in France. And they mainly have 3 services to offer to their customers that are really different, but mostly transactional stuff, OLTP. So they do micropayment on the internet, some telecom services, and advertising. Why it's important to give you that context before diving into the high availability stuff is that mostly high availability is a compromise you need to make in between different things. And so understanding what the business is about really helps doing the good compromises. So as a DBA, if you're asked to implement high availability, mainly my advice is that your first question is, what's the business need? What do you need? Why do you think you need high availability, and what does it mean to you? So, and the reason why iMedia has been happy with PostgreSQL up to now is the very good capability of PostgreSQL to adapt to changes. We will see what that means in the next slides of the talk. So usually what the business wants is reliability, stability, performances, all the jazz. So they don't want to cut off on performances just because you want some more reliability. And that's where you begin to talk about compromises. And the question on the top of the slides is one of the most important. When we talk about high availability and PostgreSQL, we really need to think, do you want availability of the data, of the services, or do you want both? Because the way to implement that is different, and the set of compromises you will make are not the same. And we will see that in some level of details. And what the business wants to usually is have their customers happy about the business you provide to them and be able to welcome as many new customers as possible. So you need to prepare an architecture which will be able to help you reaching that goals. So how do you do that? First step will be to isolate. Sorry, I'm confused. So let's talk about what is availability, what is durability. Everybody heard about the ACID property of modern relational databases that we've been having for the last 30 years. So the durability is the D in ACID. It means that as soon as a transaction commits, the system is not allowed to forget about it in any circumstances. So the usual test for durability is that you run a test and you unplug the power on the server. You plug it back and you look at any transaction that you know has been committed must be on the server. Okay, so that's the durability. So you're not supposed to be losing any data anytime. Availability means you have access to the data that is durable at any time. And then, so the French title of that talk was a little complex and involved all those 4 words. So that's the glossary we will be using. Architectures, that's how to organize things so that you can reach availability and durability. And what is replication? It's just a way to implement them. So if someone asks you to implement replication, that's the wrong question. Replication is just how to do things. It's not what you want to do. Nobody wants to do replication. They want availability or they want something. If they get to you and say, I want replication, the question is why? What are you talking about? What do you think we'll get with replication? And we will see you have lots of solutions with PostgreSQL, each with different set of compromises for different use cases. And so, again, really you have to think, do you want availability of services or data, or both? But you need to think about it. So for this talk, we're going to start with a single project that we will make evolve from slide to slide, and we will add in requirements to it. And so we will begin really simple. It's a really simple project. You're a startup, you're just beginning, you don't have users yet. And then you will add some users. You will want availability of data, of services. You will add some, you will want to have some load and write balancing. So let's start really simple. It's all on the same box. All right. It's often the case. You start a new project, you don't know where you're going yet, so you put it all on the same box. I've written here Apache as an example of an application server, but you can, in your mind, replace Apache every time you see it with whatever you're using. It would be Ruby on Rails, it would be some Java framework, it could be whatever you want to. I've just written Apache because it's easier, everybody knows about it, it's easier to talk about it. But we don't really care, we care about the PostgreSQL side of things. So we start with that. First question, traffic growth. Now you get new users. Is your single machine able to cope with many new users? Usually, quite quickly, it's not enough. So the next step is to care about service availability. What happens if you reach out of max connections? Then you can't anymore accept new users because you don't have connections to serve them. So you need a way to leverage, to solve that problem. If you're using persistent connections, that problem is only worse. So the solution, who know about pgbouncer already? Who's running it in production? Okay, some of you, good. The other one, look at it. It's really great. Here is what you will do with pgbouncer. So pink boxes, those are the application server. The green one, that's your database. Usually the first step, you install pgbouncer aside the database server because it will handle many parallel connections from the clients, and it will manage to handle them with a few server connections. I don't go into details about how it does that, because that's out of the scope of this talk, and we only have 1 hour. But read the documentation. It's a really nifty tool. And sometimes you prefer to have the pooling happen on the pink boxes on the application servers. If you do the pooling only on the application servers, you risk reaching again the max connection setup each time you add a new box. Okay, so you have traffic growth. 3 boxes is not enough. You add a 4th one, so you add a 4th connection pool, and so that's another 20 connection to the server. If you add too many of them, you will again reach max connection. So often enough, you have pgbouncer both on the application side and on the server side. I've heard yesterday a use case where they have 4 levels of pgbouncers, one after the other. So, yes?
There are 3 different ways to configure pgbouncer?
Yes, I won't have time to address that question in the talk. Come to me after it. So the question was about how to set up pgbouncer. And it's an important question, and I'm happy to answer it, but just not in the talk. Don't have time. So here is an example of the level of flexibility you reach with PG Bouncer. You have to watch for this column here. That's the number of clients in average connected to the server. And there is some magic here. So now that's the active connections on the server, and that's how many connections the server is seeing. So we had more than 400 guys connecting to the server at the same time, and PostgreSQL is only seeing 4 of them. So you can handle some growth. And why it's important, if we get back to that drawing, is you want service availability. So you want to, if you have that many new customers using your service, you want to be able to add some pink boxes, as many as you need to for the application server, without maxing out your database server. So PG Bouncer is really nice for that. So let's hop into durability. Who's doing backups? Oh, so for the aim of that talk, I will consider that the people who didn't raise their hands are not yet running PostgreSQL in production. Okay, that's the only sensible answer. If you're running in production, you have backups. So who have automated nightly or weekly backups? All automated. Good. Who has automated restore? Okay, so you don't have backups. Okay, that's as simple as that. I'm talking about availability of data and architectures, etc. But if you're not testing your dumps, well, you don't have data durability to begin with. So there is no point continuing with this talk. Go fix your script. I'm waiting for you. No, maybe not. But that's the spirit, really. So that's the first step in data durability. If you want to be sure to be able to have your data around, dump them regularly and test the restores. And when you do that, we talk about data retention, usually. So either you do, the classic model is that you do nightly backups. You keep them for 7 days, and each week you keep one of those for several months, and each month you keep one of those for several years. And if you're a funny business like banking, maybe you're asked to have 30 years of backups. In which case, if that's a business requirement, and you want data durability, you really need to think about the storage medium you're going to be using. Because 30 years from now, the hard disk that is spinning on the server will not maybe able to spin again. So that's a hard question. You need to think about it when implementing high availability architectures. That's part of the game. So if you use pgdump, you use pgrestore. That's good to address the first parts of the problem, but the restoring time, even the pgdump time, but in case of a crash, you want to restore the last backup, right? So you're concerned with the time it will take to restore the data, because with that technique, you are able to ensure data durability. It's really important. But what about data availability? While the restore is going on, nobody can use the data. You have to wait for the restore to be done. So it's not great for availability of data. That's why we have other techniques. So who's familiar with the idea of point-in-time recovery? Okay, great. That's new. That has been new in PostgreSQL in 8.1. That's like 10 years ago. So you can really trust that it's working. We added warm standby in 9.2, and I will detail it in the next diagram. We will see it in images. It's easier to explain that way. The basics are that you are using archive command and restore command to ship the write-ahead log files from one server to the other. So what happens with PostgreSQL is that any change you make to the data is first logged in the write-ahead log. We call that, of course, to simplify things, that thing has 2 names. It's either a WAL files or a PGX log file. But those are the same thing. That just means that in case of a crash, we can read from that information, restore the data we had committed, and allow you to use the server again. If you do that and you ship away those files to a second server, then you implement warm standby. That was the way of doing it at the time. And in those proven architectures I want to talk about, I've been using both wallmanager.py, which is included in SkyTools, in the SkyTools package. It's the solution for availability by Skype people. And I've been using Wally, which is from Heroku and allows you to archive and restore to and from Amazon S3. So if you're running on the cloud, have a look at Wally, it's really good. The new tool to solve that problem is called pgbarman. So have a look at pgbarman. The only reason why it's not written in there is because I don't have yet like 1 year of production story to tell about it. But it's really good nonetheless. So here is what it looks like. So remember the previous diagram, we still have the pink and green boxes, and we just added a blue one. The blue one is the warm standby. What happens is, as the master server is working, it will thanks to archive and restore commands implemented by Wall Manager, for example, it will send the wall files to another box, and that blue box will be able to recover from those files, allowing you to have up-to-date data. So if you implement that, you have a better data availability, because you don't need to wait for the next PG dump to have fresh data. It's happening real time, or well, not real time for real, but it's way better than with PG dump already. And so that was the first step, warm standby. So nowadays, we will see just later, we have hot standby instead, and I will tell you why hot is hotter than warm. So mostly you won't implement that nowadays, but it's important nonetheless to understand that part, because it's really the basics that all the replication stuff included in PostgreSQL have been built around. So it's going a little quick in here today. If you're not familiar with the techniques, I guess I've left many gaps open. But if you want to understand PostgreSQL replication and how to implement it, have a look at that technique. It's the basics. And when you understand that, you will easily understand the rest. So now, what about service availability? Because if we look at that diagram and we have a crash on the green box, we'll still have to go from that to the blue box and redirect all the pink box connections towards the blue one. And we have to be careful when doing the switch, not to have been losing data. So either you compromise on the service availability and you do the switch over as fast as possible, and maybe you lost some transactions, or you want to compromise on the data availability. So when a crash occurs, you want to reboot the green box, have a look a serious look at it, be sure that it's lost, and only when it's lost you will be able to switch, because you really want that data. And it's not a problem if you're not reopening the service yet, you want the data. Okay, so with that architecture, that's the compromise I've been talking about in the openings. In case of failure, you have to choose between data and service. With that technique, there is no other answer. So we will try to bring on the table some new techniques, right? So if you care about service availability, the best answer to that is to talk about it with the guys making the application. Because in that example, we were able to split in between the part of the application that's dealing with setting up the service and the part of the application that is used to get money from the customer, basically. And if you can do that, you separate that in two different systems that are autonomous, and you can have different set of compromises on each one. The way to do that with PostgreSQL techniques is to implement it with one of those logical replication things. The solutions are called, so Slowney is the first one that existed in PostgreSQL, and then now we have LongList and Bucardo, and my personal preference is towards LongList. But the three are doing about the same thing. Bucardo is a little different. What they do is install triggers on your database and register each and any changes you're making, and then they allow you to replay those changes to another database. The good thing about that is that the two database servers, the provider and the subscriber, they are different systems, and they're really loosely connected. They don't have to be the same at all. So you can have different tables, different indexes. It can be all different, and you just ship the data from one to the other. So it's really loosely connected. It's really nice. If you use LongList, then you can even leverage the transport mechanism it's using, called PGQ, and you can implement your own specific batch processing of the data when you want to ship it from one server to the other. So you can have processing in the middle, application processing, whatever you want to do. And it's still transactional, so I have some details on the next slide. That's PGQ. It looks like that when you implement it. So this time, the colors are meaning something different. Okay, this time we have two production services box running PostgreSQL. The pink one is backend, the blue one is the production service, so the one that you really depend on to get your customers' money, for example. So in the case of iMedia, where I implemented that kind of solutions, it's really, the blue box is really getting the money from the customers directly. It's internet micropayments and extra on the phone payments extra. So you want that box to be available all the time. Availability is really, really important. On the back end, you set up the document you want the people to pay the access for. So if the backend goes down, the customers will be unhappy about it because they cannot do the setup they wanted to do. But the money is still incoming. And when you explain that to them, it's easy to get them to go with that. Okay, it's a good failure scenario. And the daemon box in the bottom is running some custom. In that case, it's written in PHP. You can do something else if you have more taste. Sorry. And so it's running that to compute some real-time statistics. It's basically the dashboard of the customers. So they log into the backend system, and they can see what did happen just now on the OLTP system. So they can see how much money is flowing into their account. And that's thanks to PGQ on the bottom of the drawing. So with that case, the replication in between the PostgreSQL boxes is made with LongList. So it's really two independent systems, and the application really needs to know about it. You cannot implement that without talking to the developer team. There is no way you can bring that on the table without involving the application development team. But this is the simplest way to implement high availability in that case. Okay, so again, when asked to implement high availability, it's easy to think that's a DBA problem. Maybe I need to talk to the system guys to implement it with the right network or hardware setup extra. But if you involve the application guys, you can have a much better, much more flexible solution to implement. And PGQ, who's using PGQ already? Okay, really a few people. I'm not surprised, but okay. We use that in the PostgreSQL.org infrastructure. That's how good it is. It's really nice. If you have, as soon as you want to offload some of the processing out of the interactive session with the user, think about PGQ. It's exactly made for solving that problem, and it's still transactional. So if something bad happens and the transaction gets a rollback, it won't happen. It won't be seen in the queuing. So you don't have to care about such problem. Also, if you're doing several different things in the same transaction, PGQ guarantees you that all of that will happen in the same batch when you're batch processing the transactions. So you still have the transaction boundaries about what's happening on the production server. And you have a really clean little API to be using it. By default, it's written in Python, so you use it in Python. I've written a lib to use it in PHP because in iMedia it's a PHP shop, and so they have all the model classes, and they have loads of things implemented already in PHP they want to reuse in the batch processing. And having done that, I can tell you that if you need to do that in Java or whatever, it's really easy to port PGQ to any language you want to, because they have been really smart in implementing it. The API implementation happens on the PostgreSQL side. So all you need to implement PGQ for your own batch processing is to be able to connect PostgreSQL and call store procedure. And that's it. That's the API. So whatever the language or system you're using, you can use PGQ. And it's solving a lot of problems for you. So have a look at it. And you can, nowadays, you can even have cooperative workers, which means that you can have several workers splitting off the event stream. Each of them is processing another batch. So you can leverage that if you need to. So okay, I will not insist much more than that, but have a look at PGQ. It's, for me, it's like the missing piece in the PostgreSQL offering, but it's not missing actually, it's there, so just have a look. So we are continuing the thing. With the previous architecture, we had some more flexibility in the availability compromises we want to be able to make. But we still want to be able to do both data and service availability at some point. So let's see some more techniques to get there. So in 9.1, we got hot standby. In 9.0 actually, but missing some little options. So I would advise to consider 9.1, to prefer 9.1. So why hot standby is hot and warm standby only warm? The reason why it's hot standby is that you have a primary server and a standby. You can use the standby as a read-only server. And when you do that, in case of a promotion of the standby, usually it means that the master is crushed, right? So you have some read-only load on the standby, and when you promote it, no query is affected. They continue running. Your read-only load is unaffected by the standby promotion. So it's really it's hot standby because you won't have service interruption when you promote it. Okay? Warm means that you're using it in a way, and when you promote it, you need to restart it or something. So you're cutting all the connection, something is happening, and then you can use it as the new master. With hot standby, there is no service interruption. So that's a way to get a better service availability. With the 9.1, you can implement either synchronous replication or asynchronous replication. So the difference is a little subtle. The difference is what does it mean as the application to know that the commit has been done. If you're asynchronous, it means that the commit has been done on the primary server. And that's it. And later on, it will be done on the standby. It's asynchronous. If you're in synchronous mode, the client application only knows about the commit having been done when it has been done already on both the master and the standby. So if you have a really high availability requirement, you can implement it with PostgreSQL in a way that any transaction you make, when you commit it, when you know it's been committed on 2 servers. So you can lose any server you want, you still have the data. online and ready to go. So that's what it's about, the synchronous part. And the problem is that, of course, you need now to wait for the standby to have the information related to your transaction that you just committed. So it's slower. I'll get back to that. The other thing is how do you send the information to the standby? And what's really good about it is that it's using the usual connection facility that you have with PostgreSQL, and that's called libpq. That's the implementation of the PostgreSQL protocol, and it's what we use for the hot standby connection, which means that you have all the usual PG-HBA setup. And do you see the picture over there? It's not exactly meaningless. It's an open door with all your data, all the bits you have in the server, thrown away through the door so that anybody can read them. So if you're a little concerned about security, that's not what you want. But with using libpq means that you can implement SSL to encrypt the communication, and you can even go as far as having a certificate authentication when you want to do replication. So you can do that replication, that streaming replication, you can implement it in a very secure way if that's what you need, if you're on a network you do not trust. The way to implement that is using recovery.conf and have a look at the PostgreSQL documentation if you want to know more about that. As an aside, if you're interested into any level of details about anything you hear about PostgreSQL, the first thing to do is to look at the official documentation for the major version you're using. You could go and use Google search, but then what you will find is some blog posts. And if the blog post is like 5 years old and the best way to set things up has changed in between, you won't know about it. The PostgreSQL documentation is really great, so that should always be your first stop. Go look at the documentation, really. It's worth it. We are expending a great deal of work into maintaining that documentation, and so really have a look at it. You will be happy you have done it. And so back to the performance problem and flexibility viewpoint. You can switch in between synchronous or asynchronous replication mode per transaction. So that's unique. There is no other database in the world that I know of that is able to do that. What that means is that you can have a trigger, for example, that looks at the balance difference. For example, you're putting some more money on your account, and that says, okay, if that's worth more than, I don't know, $100, then I'm switching to synchronous. I don't want that to be lost, whatever happens. If it's less than $100, the cost of waiting for the standby to answer me is not worth it. So it's asynchronous. That's a compromise I'm ready to make for the business. Okay? So you can, it's always the same compromise we're talking about since the beginning. It's the data availability against the service availability. And what data is available if you need to keep the service continuing. So when you have no time to look after the data, what do you have? If you're in synchronous replication, anything that's been committed is already on the standby. But it's costly to do so. And you can switch that in a transaction, which means in a trigger. Okay, that's a level of flexibility to implement your own compromise that is, as far as I know, unparalleled. So that's really important. And that allows you to reach good performance level when implementing even synchronous replication. So it's really known that synchronous replication means it runs slower because each time you commit, you have to wait for the standby. But if you can do that only when it's important, most of the time it's running as fast as usual, and when it's important, it's waiting a little more, but the overall throughput is not that much affected, okay? So you can have a mix in the same server, in the same cluster setup of synchronous and asynchronous, so that you can reach a good compromise on the availability of data with keeping a good performance level. So you can have it both. You can have it all with PostgreSQL. And if we mix and match everything we said up to now, here is what it looks like. So at first sight, it looks a little airy, a little too complex a setup. I've been told once that if the setup is too complex, by definition, you will not have high availability because it's too complex to have availability. What you have to remember when reading that, you have to split it in the middle. The middle rows are really loosely connected. That's the techniques we've been talking about before. It's long list and PGQ. So it's really loosely connected. So what we have here is two autonomous systems with different set of compromises for availability, loosely connected with some logical replication stuff in between. So if you're concerned about the complexity of the setup, well, just look at half of the screen at a time. Because if something bad happened to this part of the screen, the other one is not concerned. It will continue running. The long list is quite resilient to do network failures or the other guy disappearing. It will just spit out some errors in the log every 20 seconds. And when the other guy is back, the replication is flowing again, and it will catch up the lag. I've seen that happen in production more than once, and it really just works. So the failure cases you're interested in that case, is when you lose one of the green boxes. And the solution is to switch to the blue box. So it's a failover that you can do. You promote the standby, and off you go. And if you're using out standby, you can use it as a read-only server. And if you're using wall streaming, you have the option of doing asynchronous replication, in which case the usual lag is in the ballpark of 200 or 400 milliseconds. And if you're synchronous, any data that has been committed on the green box already made its way to the blue box. So at the time of the promotion of the standby, you already have the data. So that's the data availability part. Okay. But we have some more. This diagram you just saw before is not implementing right scalability. So if I show you, so we are going to talk about sharding. But if you look at that, if you're thinking about read scaling, so the scaling is important not for the data availability, but for the service availability, right? If you want the service to remain available, even if you have a high load, you need to spread the load, or the service is not available anymore. And so in this talk, we are trying to reach data and service availability. So that's why we expand on that. So here you can spread some reading on the blue boxes. It's read-only, but you can spread the read load. But any write that happened on the green ones is going to happen on the blue ones too. Any single write is made on both boxes. So you didn't help yourself at all with your capacity to handle writing transactions. So how do you do that? The way I've implemented to do it is peer proxy. Peer proxy comes from the Skype team too. So they have really developed a full set of solutions for their availability and scalability problems. And their solution to spread the write load is peer proxy. What it does is offer a stored procedure API that allows you to run a function on a remote server. So who knows about foreign data wrappers? Not many of you. I wanted to say it's a function-based foreign data wrapper, but that's not helping many of you. So it's really, when you call a stored procedure on a proxy server, it will connect to a shard and run the procedure over there and get you back the result. So with that, you can distribute the load, and here is what it looks like. So you have, in that diagram, as many application servers as before, and we are zooming into the first one, okay? If you see the first layer of rows, I didn't draw any arrows from the second and third front-end server. That's just because it would be, it would make the thing really complex to read. So let's zoom in on the first one. What happens on the main difference in this box in pink over there is that now we have PostgreSQL and PL proxy running. So you install a PostgreSQL instance on the application server. Well, you can do it in a second layer if you want to, but you can do it directly on the application server. But this instance is not running any data for you. It's just a stored procedure proxy, so that the application will call a stored procedure on this local instance of PostgreSQL, but this procedure is going to be run for real on one of the green boxes, depending on the sharding. So there is a hash on some argument, and depending on the hash value, you will run on one of those partitions. So that's why I did label them P1, P2, P3. That's the partitions. Oh, there is a little bug here. If you're using PL proxy, the first one is called P0 each and every time. So, okay, I will need to fix that. And if you want, so that helps you spread the write load, because now, when you have transactions that want to write data on the server, it will write on one of the three I draw in that schema, not the three of them. So that helps you spread the write load, and so you can reach a better service availability with that. And if you want data availability, you still need hot standby for each of the PostgreSQL servers. Oh, and by the way, if you have hot standby, you still need backups. I didn't stress that out, but even in that case, you still need backups. Sometimes you don't have the budget, the money to run one hot standby server for each partition, for each shard. But with PostgreSQL, you have a great flexibility even there, so that you can actually implement it that way, which means that you have a single server that is running as many PostgreSQL clusters in parallel as you have production shards, and it will keep all the data safe for you. The compromise you're making here is that in case of a crash of one of the main shards partitions, a green box, then mostly I bet that you won't be able to directly use the hot standby as the new production box, because it is handling the load of doing the replication for all the other boxes in the production system. So it's a budget compromise. If you don't have, if your project is not worth spending that much money so as to have a second hot standby server for each partition, you can do that. The compromise is that in case of a failure of a green box, you have to bring a new one on the table and replicate back from the standby to this one and then use it. So you can have a huge downtime window, but that's a budget compromise. So I did implement it that way already in a project where it wouldn't be worth, well, the management team did say, I'm not spending the money to have that cool diagram. I'm spending the money only to have that, and I understand that we have a bigger downtime window, okay? But that's a management and a budget decision. The good thing about it is that with PostgreSQL, it's easy to implement it that way if you need to. And so we've been speaking about services availability, data availability, read spreading the read load on the hot standbys, spreading the write load with peer proxy on some shards. What about having both service and data availability? Well, if you want both, you need 2 standbys, and there is no way around that. The only way around that is that you have a compromise leading you to either data or either service availability. But if you want both, it's the first way to read that is the classic availability thing. The reason why we have drawn 3 pink boxes over there is that if you lose one application server, you want to still have 2 of them, because as soon as you have only 1 of them, you cannot speak about high availability anymore. So it's the basics. You want 3 servers. With PostgreSQL, it would be the same thing. If you lose the master server here, the green box, you will want to promote one of the standbys and still have a standby. So the other one will have to switch over to the new master. So one of those will be the new master, and the other one will have to be a standby of the new master. Okay? So it used to mean that you had to implement archiving in that case. So both streaming replication and archiving. But thanks to Aki over there in 9.3, you will be able to do that with only streaming replication. And thanks to some others development, we have in 9.3 a much reduced timing to promote the server. So you can really fast promote one of the standbys and have the other one follow on the new master. Another reason why you need 2 standbys is the queries conflict resolution on the standby, but I'm not sure I will have enough time to cover that in the talk now. So to make it shorter, just remember that if you want both high availability of the services and the data, it's more complex than it sounds. You have loads of different techniques and software to implement it in PostgreSQL, lots of solutions. Most of them that I've been speaking about are included into PostgreSQL itself. Some of them, like Landiste, PGQ, Wall Manager, Wally, and pgbarman, are external projects. But if you want the full thing, you will need to look at that, okay? And if you want the whole picture, if you really want to be sure, you need 2 standbys for each master. So, this whole capability of PostgreSQL didn't just happen. It did happen over like 8 years now, or maybe more. It began with the implementation of point-in-time recovery in 8.1, years and years ago now. By the way, who's running 8.1 in production? Okay, good. Don't do that. It's too late. 8.2, anyone in production? Same thing, you shouldn't, so nobody, cool. So in 8.2, we got warm standby. So it's the ability to have the standby box do online point-in-time recovery, if you want to call it that way, so that it's ready to serve in case of failure. Then we got PG Standby to help you implement that easily. And that was deprecated quick enough by streaming replication on hot standby. Technically, hot standby is not covering streaming replication, but well, we can mix and match the terms somehow. And then we got the synchronous replication. That, let me insist another time, it's really unique in the way it's implemented in PostgreSQL, in that you can really switch that per transaction, which means, for example, in a trigger. That's really unique. And that allows you to have the best data protection you can imagine, while at the same time having a level of performances that is not compromised by the data security. In 9.2, we added cascading replication to that. There was not a single diagram here with cascading replication architectures. That's because the angle of that talk really was to show you things that have been running in production for some time and that has been proven, and you can trust those ideas as something that works on the field for real. And I don't have that level of experience with 9.2 yet, okay? But it's there, you can use it. Go with it. Cascading replication allows you to have a standby connect to a standby that connects to the master. And you can, I think in some tests, Tom over there did have like 128 standbys chained one after the other. So you can go crazy that way. Maybe you shouldn't, but if that's what you need, you can have a try. The next step of the in-core replication is bidirectional replication. Why it's called bidirectional replication? It's because everybody wants multi-master, but nobody agrees on what it is. So if we call that multi-master, everybody in the world will be disappointed that we're not solving the problem they had in mind when reading multi-master. Okay? So to make it short, multi-master does not exist. Nobody is able to agree on what it is, so it's a dream. But bidirectional replication means that the flexibility we have seen with long list in the slides before, where you have two servers and the two of them are the primary, the provider server for some tables, and the subscriber server for some others, and you have cross replication that way. That's bidirectional, and that's a way to implement multi-master. Okay, so we are working on getting to bidirectional logical replication in core, and in 9.3 that meant some cornerstones that we needed. It's a refactoring, some new internal stuff did happen. We had event triggers to be able to later implement the DDL changes. So it's on its way. I've written there 9.4. But nobody knows what we will get in 9.4, okay? It's an open source project. So if we are really lucky, we will be able to talk about bidirectional replication in core in 9.4, but nobody knows. Okay, that's it. Any question? No? Okay, great. Heikki. Yeah. If you do a Google image search on core, that's what you find. And I found it cool, so it's a core. So we're talking about in-core replication solutions, and that's a core.
Want to replicate that?
I'm saying it looks cool. Over there was a question. Yes?
What would you say is a good way to implement the trigger file on standby?
I'm sorry, I'm not hearing you.
Saying the 9.1 on standby, what would you say is a good way to implement the writing of a trigger file?
Come to me after the talk. I'm not hearing you. I'm sorry. Okay, I guess it's over. Thank you.